We're asked to factorize this cubic polynomial and we're given a factor. Brilliant. We don't have to use the factor theorem or anything to find one. We're told that x minus 3 goes into it. So first thing to do is divide by x minus 3. There are other ways of factorizing it, and you might be able to do it more quickly, but this is a tried and tested, efficient algorithm. So I'm going to go with it. Okay, x's into 2x cubed go 2x squared. Multiply back through. And then subtract minus 7 minus minus 6 gives me minus x squared. Bring the 2x down. Then x is into that, go minus x. Is 3x. Subtract them, these cancel, we're left with minus x plus 3. X is into minus x, go minus 1. Okay, and this is always reassuring because we get 0. If you didn't get 0, it means you've made a mistake and you should look back through because there must be a remainder of 0 for x minus 3 to be a factor. Therefore, f of x is going to equal x minus 3 multiplied by 2x squared minus x minus 1. And we just now need to factorize the right-hand bracket. So if it's going to factorize, it's going to be 2x and x. And then it's got to be 1 and 1 to work. So to get that minus x, there's going to be a minus here and a plus 1 here. And that is our answer to part 1. Just going to quickly say there is a nice way, well, I've seen lots of people do it with their calculator if they struggle with factorizing. So I'm just going to show you that. So I'm not going to worry about the x minus 3. I'm just going to focus on the 2x squared minus x minus 1. Okay, and we get 1 and minus a half as our solution. And you can kind of, so, 1 and minus a half. So that might give you that to factorize, but there's a 2 in there somewhere. So it's, if you then multiply through by 2, you're going to get what I got there. So it can, if you really struggle with factorizing, actually in A-level maths, your calculator can help you and sort it out. Sorry, trying to get rid of that. Part 2, sketch this graph, including the coordinates of any points of intersection with the axes. Okay, I'm actually going to fit it in over here, I think. So we have that it's going to go through 1, and it's going to go through x equals 3, because this is from the roots, and minus a half. And then looking at it before we factorized it, we had a plus 3, so that gives you your y-intercept. So that's always a good shout. Find your roots, which we've already done in part 1, essentially. We didn't write them down explicitly, but we factorized it, and then your y-intercept. And then just think about the shape of the curve. It's a positive cubic, so that means it's going to look like this or something, but it's going to be the top one, basically. It's going to come up, it's going to come back down. And I don't know about the turning point. I'm not saying the turning point is at 3. I think it might be just after 3, but it's okay. Like, you're not going to get marked down on that or anything. That is a sufficient sketch. Okay, happy with that. Right, now we're asked to solve the inequality f of x less than 0, giving our answer in set notation. And this, in fact, is very quick once you've got the sketch. So where is the graph less than 0? Well, it's less than 0 here and here. So part 3. Okay, it's going to be x is less than minus a half, or x is between 1 and 3. Now, it wasn't allowed to be equal to, it was strictly less than. However, it's asked us to give our answer in set notation. Now, if you can't remember set notation, this should still get you 1 mark, so don't just leave it out. But this is set notation. We include the set of x. such that. That's the main bit you've got to remember. Then you basically write the same thing out. And the set of x such that. Okay, you just got to realize then that you put the union in, because this basically means or, whereas that means and, has to be at the same time. Okay, this is going well. Right, final little bit. The graph of f of x is transformed by a stretch parallel to the x-axis, scale factor a half. Okay, parallel to the x-axis. So that's going to mean that f of x goes to f of 2x, because you take the reciprocal of whatever the scale factor is. Because if you have, f of kx means you have a scale factor of 1 over k. So I'm basically doing the opposite here. 1 over 1 over half is 2. So this k is 2. So all I've got to do is write down my equation with all my x's replaced by 2x. So I wonder if I can just take the factorized form and write that. So transformed function is going to be 2x minus 3, and then 4x plus 1, and 2x minus 1. So this is definitely accepted by the answers and is the quickest way of doing it. You could alternatively, like I said, put it back into the original, and it doesn't take loads longer. You get this instead. Brilliant.